We will start with new topic, system, which is also important in signal regard. System. What is system? Basic definition of system and different classification of system. Definition of system is a mathematical model of a physical process that relate input to output. Input means excitation. Output means response. System is a mathematical model of a physical process that relate input signal to output. Different classification of system. With memory system, and without memory system. Memory system. First classification of system is directly relate excitation to response. System with memory system. A system is said to be memoryless. System is said to be memoryless if the output at any time depend on input at that time. Same time reference means example, current and voltage relation between a circuit. For a circuit contain only resistance R. It is a memoryless system. V equals to IR. Ohm's law. It is a memoryless system. Another example, if yt is integration from minus infinite to t x tau d tau, it is a current relation when circuit have inductor or capacitor. These two systems are with memory system, means inductor and capacitor providing memory to the system. With memory system, providing memory to the system. One more example, with memory system, k equals to minus infinite to n x of k. Yn generated from xn from all the previous value below xn, x of infinite. It is with memory system. All the previous value added in the output. Second classification, causal and non-causal. What is causal and non-causal? A system is called causal if its output at t equals to t0 depend on input for t is less than t0, means past value plus present value. Output depend on past value and present value of input. Does not depend on depend on future value. Future value does not depend on future value. Let's take an example for causal and non-causal. Let's take an example for causal and non-causal. Let's take an example for causal and non-causal. If yt is xt plus 1, we have to check whether system is causal and non-causal. Just putting y equals to 0, x equals to 1. At t location 0, output y0 generated from input location 1 means future value of input. It means it is non-causal. One more example, xn yn equals to x of minus n. At location 0, x is again 0, no future reference. 1, x of minus 1, no future reference. Y of minus 1, x of 1. There is future reference, means NC. We have to search out for input for which it is non-causal. In all the system for causality, non-causal, we have to check for which input it is non-causal. If any future reference is there, it is non-causal. One more example we took. In that example, we consider yn equals to summation k equals to n naught to n x k. We want to check whether it is causal or non-causal. We took two cases. First case, if n naught is 0, this expression is reduced to 0 to n x of k. By putting different values, I check whether it is causal and non-causal. First I put y minus 1. Summation k equals to 0 to minus 1 x of k. For this x of 0, x of minus 1, y of minus 1 means at time reference minus 1 x at time reference minus 1 output depend on future value time reference 0 means system is NC, non-causal. If we put n0 equals to minus infinite, yn is now revised k equals to minus infinite to n x of k, y of minus 1 summation k equals to minus infinite to minus 1 x of k. Y of minus 1 is accumulation of minus 1, minus 2, minus 3 and up to minus infinite, means no future reference. Means system is causal. System is purely causal, means n not decide system is causal or not. If n naught is greater than n, system is non-causal. If n naught is less than equals to, then system is causal. So we check for non-causality. If no point, we find no time reference point, no point, then system is causal. Otherwise, system is non-causal. We took another bifurcation of system: linear and non-linear system. For a linear system, it follows two ideas: superposition theorem and homogeneity. Superposition and homogeneity. What actually mean by superposition? What is superposition? Means a input is applied x1t, result will be y1t. x2 is applied, result will be y2t. If both are combinedly applied, result will be combination of these two. We can say in network theory also, a system with 5 volt input, result will be 15 volt, 15 ampere. With 10 volt input, result may be 30 ampere. If combination of these two applied to the system 25 volt, result will be 45 ampere. Means superposition. Individual input produce individual output, sum of the individual input produce sum of the individual output. Means output due to sum of input must equal to sum of individual output. This term is mixed with homogeneity and then conclude alpha x1t plus beta. Homogeneity means just scaling. Homogeneity added with superposition. So linearity described as beta y2 t. Let's take example. Check whether system is linear or not. Check for linearity. Yt is given us in this way: xt minus 4. We want to check system is linear, whether linear or non-linear. If x1 input is applied, y1 is x1t minus 4. If x2 input is applied, y2 is x2t minus 4. If combination of these two applied, x1t plus x2t, combination of these two applied, result will be y. x1t plus x2t multiply with x1t minus 4 plus x2t minus 4. Both the term y dash, y and y dash, both term are not equal because there is 4 term and in previous case only 2 term. There is 4 term and in previous case is 2 term. Both are not equal, system is non-linear. In previous case we find only 2 term, 2 combination. In this case we find 4 terms. Means both are not equal, system is non-linear. Other example of linearity: integration and differentiation are linear system. Modulus is non-linear system. Exponential is non-linear system. Sampling is linear system. Move to next definition, next bifurcation. Time invariant variant system. If system following time invariance property means time invariance, but not time varying system. A system is called time invariant if a time shift may be delay or advance in input signal causes same time shift in output signal. Example, we perform an experiment in engineering lab, we got result 5 volt. We perform an experiment, we got result 5 volt. After 5 days, we perform same experiment, we got same result 5 volt. Means system is time invariant. It means same amount of delay, 5 days with all the input delayed by 5 days, result will be again 5 volt. Means system is time invariant. Delay input and delayed output both are equal means system is time invariant. If it is not, system is time variant. For example, I took yt equals to x3t. Time invariant system is also known as time independent system. Means time invariancy can be checked with two ideas. Delayed input. Input is delayed by some amount. Let's take example. Input is delayed by 3t delayed by t0. Delay by t0. And delayed output. Now output is delayed by same amount x3 t minus t0. If both are equal, system is time invariant. If not, if equal, if not, time varying. In this case, both are not equal. Time varying signal. Same idea we apply with a question come in GATE question paper. Yt equals to minus infinity to 2t x tau d tau. We want to check time invariant or variant. We have an idea to check delay input and delayed output. We have to check if both the condition, in the both condition we have same result, system is time invariant. We have to check. First we delayed input by some amount. We say delay by p amount. I delay input by p amount tau minus p d tau. Change of variable tau minus p equals to k, d tau equals to dk. Minus infinite by putting this d limit to p plus k. By putting the limit into this expression is now minus infinite to 2t minus p x k dk. New revised delayed input expression is delayed output expression is complete expression is delayed by some amount p y t minus p minus infinite to t minus p x tau d tau. Compare these two expressions. Both are not equal. Both are not equal because limit in the both case are different. So this is time varying system. Time varying system. We can check time invariance from delayed input and delayed output. First we delay input by p amount in this integration and modify the limit. We got the result. And second, delete the output. T is replaced by t minus p. Wherever t occur, t minus p is replaced. Both are not equal, time varying system. Both are system is time varying, both are not equal. Move to next. Next classification, stable system. Stable system and unstable system. We have to check system is stable or not. How can we check? A system is bounded input, bounded output. Stability is checked on this criteria: bounded input and bounded output. If for a bounded input system give bounded output, then system is stable. What is the definition of bounded input? Means input is bounded within limit, output is also yt. Output is also bounded in limit. Bounded input, bounded output. For bounded input, bounded output, we can write expression for impulse response dt is finite. For discrete, we can also write xn this. We can check system stability through this idea if impulse response is given to us. Otherwise, we applied a bounded input on system and we can get the bounded output. At that condition, system is stable, otherwise not. First example I took xt square. We want to check whether it is stable or not. We applied a bounded input ut on it. If we applied bounded input ut, then result will be u square t is again ut, same range, answer is same. Both are ut is bounded input and also result will be bounded. Means system is stable. System is stable. Case 2. Second question ले लेते हैं अपन. xt is yt is differentiation of xt. Check whether it is stable or not. Apply bounded input ut. Just applied bounded input, we got impulse. Impulse is not bounded, unbounded. It is unbounded at 0 location. So it is not stable, unstable. It is not stable, it is unstable system. Gate question. Yn equals to e power minus mod of xn. Check for stability. We applied bounded input on it. Xn equals to un. E power minus mod of un. Result will be 1. In either of case, result will be e power minus 1. Always bounded. Bounded. If we apply unbounded bounded input, then also yn is still bounded. It means yn system is always stable for any type of input, either bounded or unbounded. Either bounded or unbounded. System is always stable for either bounded input or unbounded input. Any type of input we can apply on this. System is always stable. It is stable with bounded input, also stable with unbounded input. Next bifurcation 6. Invertible and non-invertible system. A invertible system, if different input leads to different output. Different input leads to different output. Means system is invertible. A system with two different input should not produce same output. Second interpretation of this sentence. A system is invertible if different input lead to different output. Means two different inputs should not produce same output. For example, yn is summation of xn. Yn is summation of xn. Okay. It is accumulation of xn and we generate wn. yn, and result will be wn. Wn is produced from yn minus y and minus 1. It is accumulator. It is difference equation. It is called inverse system. Same result at the output. If accumulator and difference equation combinedly attach in a system, result will be same as per output. It is called invertible system. This system is called invertible system. With another example, we can check system invertibility. Yn equals to x square n. We can apply standard input. Xn equals to 2un and minus 2un. Both the input we apply on the system. We get the same result, 4un. In both cases, means system is not invertible. System is not invertible. For invertible system, yt equals to x tau d tau. It is a integration. What is the mean of integration? Means area calculation from minus infinite to t. It is unique quantity. It is unique quantity. For invertible, it should be unique. One more idea for calculating inverting system. 2 and 5. We develop a multiplier with multiply 2 and 5. Result will be 10. Single unique idea to develop a 10. It may be 1 and 10. So multiplier is not a invertible system because different input can produce 10. If there is only unique idea to produce 10, it is invertible system. So there is only single idea to integrate. Integration is only unique. Integration is only unique quantity. Area covered by this integration is only unique quantity. That's why it is invertible system. By differentiation we can get original value.